Good morning. So the programming language, the no language for the LGBT. No, not that one. That's only for transgenders. No, I use C++ or CPP for short. That sounds so shit. Okay, but what did I write that made me so excited? I have to tell a little of a story to contextualize it, so please give me a minute. This all started about 1.5 years ago. I started working in IT and often had long stretches of free time to spend, which means I was in an empty office with no tasks to do. Yes, I could have watched YouTube, but something compelled me to learn programming, so I started to learn Bash, which I almost instantly quit. Why? Because it's Bash and very limited and totally not fun. So then I started to use Python, which worked for circa half a year until the end of 2024. In this time I programmed easy and fun stuff like a mock-up OS that was supposed to simulate a only CLI-based system if it was made in the 1920s, or a really bad 3D engine. But especially after a project where I built a virtual 16-bit CPU, I noticed how slow Python can be, and so I switched. First I tried Rust because of all the good I've heard, but couldn't get warm with it. Then I picked up C++ and all my problems started to fade away. So what is important to know is that in work I can't use a regular IDE because there is a policy what software is allowed on a user's device to prevent malware infection and a whole lot of other issues. So how did I write my code? With an online IDE, which works but can be very annoying and has a bunch of limitations, like you not being able to install your own libraries or edit the file system. And because I'm sort of an autist for graphics, that was bad news for me because I couldn't use an existing graphics API like Vulkan, OpenGL, DirectX, Metal. If I find out you use Metal, I will find you. I will play you. I will murder you. Oh my god. So because I couldn't use any graphics API, I needed to find a workaround. And this workaround was ASCII charts printed in the form of a display, or to be specific, the console output. First, only ASCII charts. Then I found out that you could just use blank chars and a colored background to make pixels. And then I noticed I could use a colored ASCII char in the text formula. So I basically have this code base called LucyOS that does this graphics stuff for me. In the LucyOS framework I made some weird stuff like another mock-up operating system, a 3D renderer for voxels, a ray tracer and much more. My newest project was another mock-up OS where I once again rewrote all the code to make it more effective and easier to work with. And when I did the remake of the rendering pipeline, I wanted to add something new. I didn't just want to make colored pixels on a screen with rudimentary functions like draw line or even more interesting, draw box. So I made a function called drawChar, which, contrary to its name, doesn't just draw chars. It draws certain pre-made sprites to my display, a sprite being a pre-made asset that displays something. Enemies in old Super Mario games, for example, are sprites printed onto a screen. Okay, but now that I've set that up, how did I actually do it? How did I implement it in a way that was so cool I had to make an entire video about it? So let me just explain by just going through the function and explaining as I go. It starts with the function inputs. Here are stuff like the sprite's position, the sprite size, the sprite's color and RGB, and the so-called index. I will explain in a second. Then I define some variables. First I extract the bitmap from an array of bitmaps via the index and put it into an integer. What? Okay, that was a little confusing. So you look into an array where the templates for the bitmaps are stored and access the templates you want via the index by accessing the array at the index and saving the value into an integer. Then I create low, which is basically a 64-bit number that is all zeros except for the lowest number. The last variable I define is the flag, which I will explain in a second. Then the actual cool stuff starts. First, there are two nested loops that iterate 8 times each, so they iterate a total of 64 times, because I have 8x8 sprites. In this marriage of loops, I then define the flag operator as the result of a logical AND operation of the bitmap and the low value. What? A logical AND is just an operation that does the following. If number A and number B are both 1, it spits out 1. If both are 0, or just one of them is, spit out 0. This logical AND practically extracts the lowest bit from the bitmap integer into the flag, because if you do a logical AND operation with the bitmap and the low value, you basically say, do a AND operation with the number that is just zeros except the smallest digit, which means that the only bit that can be extracted is the lowest one. Got that? Good, because from here it's smooth sailing. Then, if the flag is 1, which only happens if the bitmap also had a 1 at the lowest position, which we extracted, it draws a pixel, or to be more specific, a box, with previously given scale and size at the same point where it should have been drawn. Now, keen-eyed viewers may have noticed that I can just always extract the lowest bit, because it's gonna stay the same. And here's where my last important line of this function comes into play. I shift the binary number of the bitmap by 1 digit to the right, which allows me to now extract every one of the 64 binary values that make up this bitmap. Okay, now that I've explained the entire thing, there's one question left. How do the bitmap values actually look? And to answer that, they are basically just a lot of 64-bit integers written out in hex code. So one final question remains. How did I get these hex maps? I downloaded them. Why should I make them myself? It would be a crazy amount of work, so many hours just wasted. Why the fuck what the fuck is that? So yes, I basically made 256 sprites by translating pixels into hex codes and encoding my images like that. Yes.
Die Menschen der Erde haben erfahren, dass es in unserer Milchstraße ein Sternenreich gibt, das sich das mittlere Auge nennt. Die galaktischen Waffenmeister sind die Verbündeten des mittleren Auges. Sie beliefern uns mit den gefährlichsten Waffen, die je ersonnen worden sind. Doch jetzt ist es zu Spannungen zwischen dem mittleren Auge und den Waffenmeistern gekommen. Holkor, einer der Waffenmeister, hat mit einer Waffe experimentiert, die vom mittleren Auge zur verbotenen Waffe erklärt worden ist.